And as they were excavating the soil coming down, they would drill more ties. So all this entire side, the wall, was supported with hundreds and hundreds of ties tying the wall back diagonally down to rock. Then they would start doing the floor. So they would start from the bottom, and they would add the structure and the floors, okay, until they came to the surface. The last slab of the surface was the plaza slab, right? And once they did that, then they went and they cut all the ties. By cutting the ties, they let the wall come in, and it's locked with the slabs. And now it's a whole stable structure. So that meant, remember, after we removed our slabs because they were demolished, the ties did not exist because they were cut. And if they weren't cut, they were probably corroded by now. So we had to therefore support the wall. And this is a slurry wall that was on the Liberty side. Remember that the crack developed, and as they were digging, we had to do something, either provide ties, new ties, or do something to support the wall. And that something doesn't really exist. The only thing that you could do is provide ties, new ties. Well, it's not an easy thing to get equipment in this mess, in this side here, to drill ties, okay? I mean, drilling is a pretty precise operation. And to get equipment on top of debris to drill, it was really not possible. So that's why we were sort of very ginger about the whole operation. And of course, it was a good thing to know what was the structure or the condition of the slabs underneath the basements also. And how do you find the condition of the slabs other than send teams of engineers underground to literally crawl within the debris and hopefully be able to map the structural integrity of the slabs? Now, I have to tell you, it's difficult to orient yourself in this building when it was a building, and to try to orient yourself in a condition of semi-collapsed condition, it's absolutely impossible, okay? But it was done, and it was done painstakingly and 1 inch at a time, and this shows the condition of the slabs that we were able to see. And the green means that the slab exists, the red means that the slab wasn't there at all, and this one means that the slab was sort of semi-collapsed, that you really couldn't count on it. So we knew, for example, that on the north side there, we had a pretty good slab here on B5 level. We had a pretty good, the green slabs on B4, a pretty good slab on B3. So we knew that the north side of the wall was pretty good. We really didn't worry too much about it, because there was sort of a stiffening elements within at several floors to support the wall. When it came to the other sides, we didn't know much about it. And we came to the Liberty side here, we had very little, almost nothing. Broken slabs, no slabs. That's why this wall sort of moved in several inches before we were able to arrest it by throwing sand and filling the whole excavated area back with sand so that it could push against the wall. Here's another mapping of the slurry wall that we were doing. And here's again the Liberty side there, and an engineer right down there trying to inspect the wall at one of the slabs that was actually good. And once we were able to dig far enough, we were able to bring in the equipment to start drilling new ties. And this is a typical drilling machine that drills through the wall and all the way through the soil, and hopefully it doesn't hit any pipes or any sewers or anything else, or God forbid electrical underground wiring. And it goes all the way down until it hits rock, and it drills into the rock, because you got to grout your tie into the rock and then tension it. So you post-tension the tie so that it's a very painstaking operation, to the point where we were in the beginning, we were able to drill only half a dozen ties. 2 ties per machine per day. We said, this is going to take forever. And of course, things became a lot more efficient once you excavated more debris, and once you brought more machines, and once people really got the hang of it and figured out how to do it and do it efficiently. And you could see the ties here. You see the ties right there. All these ties were stressed already, drilled and stressed. All these ties were drilled and stressed, okay? And placing plenty of ties, because as you can imagine, the condition of the wall itself wasn't exactly the best condition. I mean, at best, this wall was cast with a slurry system that you really don't have smooth sides, and you have seawater coming in from the river, and you have certain corrosion of the steel and so on. So just to play safe, you needed a great deal of more ties than what we had originally. What's next? By the way, at this point, before we proceed to the next, at this point, 6 months after, we have removed approximately 70% of the debris. And this is 1.5 million tons of debris. I mean, a lot of debris. Okay? The most difficult debris is still obviously within, because the deeper you go, the harder it is. And what's really delaying the operation is the tie drilling operation, because we cannot go far ahead of drilling. I mean, you can only remove so much before the drillers come in to drill ties, and no matter how experienced they are now, they are still relatively slow, because it's a very difficult operation to start with. We believe that by probably early to end of May, this whole operation is going to be wrapped up, and we're going to be all the way down. Even today, there are certain segments of the site that we've been all the way down to the last slab, okay? And of course, on the north side, there are certain areas that we need to completely go a lot further down. And each piece of the site has its own peculiarities, its own difficulties, its own structural challenges. There were structures, there were transfers, there were all sorts of things. I remember